Hello, everyone. Hi, and thank you for joining us today on our series. Today is the fourth session in our series. My name is Moria Dror. I'm the Regional Reactor PM at Microsoft. And here with me today is Atis Stein and Yarden Dror. We will work together on the series and hope you enjoy the content. So for those of you who are new to this series and to the reactor, just want to introduce the reactor to you quickly. The reactors are community spaces Microsoft have globally in 10 different locations. Basically, we offer our program in person in our location, but also online in different time zones. So pretty much wherever you are, you can check out our events, and you will probably find an online event that you can attend every day. We have events on different technologies, different time zone. All of our events are free, of course. They also offer learning events on different languages. So you can scan the QR code now and check our website to find out more on our next events. Microsoft events the Reactor events are empowered mostly by Microsoft Learn program. The Microsoft Learn program is a free hub for developers and for organization where you can access training, certifications, on-demand events, and all other all other content that it can be beneficial for you to help you really study and get new skills on different technologies that Microsoft offers. The QR code now on the screen will lead you to Microsoft Learn. I'll show you quickly how a module is look like in Microsoft Learn. So for example, here is one model that you can see that will take you 1 hour to complete. There are some modules that will take 30 minutes, some will take 16 minutes. Basically, the learning path that you choose will be consisted on a couple of modules, and the models break down to different parts where it tells you exactly how many minutes it takes to complete each part. So it's pretty easy to follow, and really highly recommend you if you're interested to learn about the technology. You can find different topics there. Specifically and more relevant for today's series, Microsoft Learn also offers the AI Learning Hub. The Learning Hub actually gathers all the AI content that relevant for you, learning opportunities, of course, or if you're interested in co-pilots or building on AI solutions and so on, you can just answer a few questions in this hub. If you scan the QR code now, you will reach there. I will also share the links in the chat soon. And you can get a tailored training program just for you. So this is the AI Learning Hub. Back to today's series. So today's session is the fourth one in the series. We already completed three sessions, and we have 3 sessions after today. You can scan the QR code now, reach to the series page where you can find the recordings of all of the previous events. We had 3 great sessions, and today's session is going to be great. Today's session is also recorded, and all of these sessions are available on the series page, but also on the YouTube channels of the Reactor. Again, I will share the link with you soon in the chat. Take a minute, please, to read the code of conduct that we follow at the Reactor. So Microsoft is dedicated to empower every person and every organization to achieve more. That includes, of course, the Microsoft Reactor events, as well as online events. So please, we are cooperate in provide a respectful and friendly environment, be friendly and patient also in the chat. So here is the code of conduct. So this QR will lead you to register to our upcoming events newsletter. So we send once a month a newsletter with all of the upcoming events that we offer the Reactor. It arrives in the first day of the month. You can also follow us on meetup.com, Facebook, and find out more on the on-demand events that we recorded on the YouTube channel. So let's start with today. That's what we are here for. The first speaker for today. So today we're going to have 3 sessions. Each session is going to take approximately 30 minutes, and it can be interactive. So feel free, please, to ask any questions that you have for the speakers in the chat. I'm going to be moderating the chat if you have any questions. So please use that. So today's first speaker is Amir Shengros, is Senior Azure App Innovation Specialist here at Microsoft. He's going to talk to you about Cloud Native 101, tomorrow's applications today. So Amir, over to you, and everyone, I hope you enjoy. Thank you.
Thank you, Maria, and thank you, everybody. It's a great opportunity to be here. Let me share the screen, and we can start the presentation. So thank you again, Moria. So as Moria said, my name is Amir Shengos. I'm a Senior Azure App Innovation Specialist working in Microsoft Israel. This year, I'm working with the digital native customers in Israel and helping them building their SaaS platform on Azure. So today, we go a bit to the beginning, not very much to the beginning, but a bit to share why we're here talking about AKS, how this goes to innovation and cloud native, and how we go from here. So we always talk about modernization, why we want to modernize, why we want to do innovation. So of course it's about generative AI in this area. It's all about it. But even before the AI, we're talking about developing new applications that's more connected to the cost, more connected to the application itself, and provide a more secure environment. And that's the way that we drive innovation. So in Microsoft, we see the innovation goes in three areas. Two of them were in the previous sessions. I hope you saw them. If not, you can, as Moya said, see the recording. So the first one is the developer compute, the environment where he developed it. So we have a lot of tools and that help in the productivity on the environment that developer is working on. The second one is the engineering platform where he saves his code when he's interacting with other developers. So GitHub is our hero solution for that. We have also, of course, Azure DevOps, but GitHub is very focused with GitHub Copilot and everything around it. And we have the environment where we are running our application, also in the development stage, also in the production stage. So we have the Azure as our platform to run our applications. So as we talked about, Kubernetes becomes the standard of the new applications or innovation. And the question is why and what Kubernetes helps you do in your application. So everything in Kubernetes is declarative. So you don't need to work around the VM sizes and all around it about the patching and all that on the OS level. You're focusing as a developer on the application itself. You declarative what the size of your application itself, what we call a pod or a container, it's built of, and what you have inside of it. We're decoupling it from the infrastructure itself, and of course supporting the microservice architecture. So every pod, every container can run alone and separate from the other services. You can scale and can get updated, and all is running inside the Kubernetes itself. Another feature that is connecting between the infrastructure and the application is all the self-service that come with Kubernetes. It's an orchestrator of your application, of your containers, and it has a lot of built-in features of self-healing, like restart the application if the probe detected the problem with the application itself. You can scale it out, you can restart it. It has a lot of stuff that you can do part of the infrastructure itself. Of course, it's part of the DevOps tool, so the CI/CD is very declarative and very Kubernetes aware. I will discuss it a bit further, but it's also containing the security and the deployment part of the environment. And Kubernetes is an open source. It's part of the open source community, and even Microsoft is one of the biggest contributors. And the Azure Kubernetes Service, the AKS, is built on the streamlined open source Kubernetes. We're not doing any fork of the Kubernetes. We're just adding more features that can be used as part of the Kubernetes, and we're bringing the service. But it's part of the open source, which by itself drives a lot of innovation, a lot of people that want to contribute, want to use, want to be part of this community of open source. So building a Kubernetes environment could be pretty challenging. Of course, we have the infrastructure side. It doesn't matter if it's on-prem or on cloud, but you have the infrastructure to take care of. You have the VM, you have the operation system, all of that you need to manage. On top of that, we have the Kubernetes platform, the runtime, and all the control plane that you need to manage, upgrade, maintain, and etc. And beside that, we have a lot of services that surrounding this Kubernetes service that you need to manage. It's from the monitoring, upgrade, of course, security, and even the authentication, and where you save the images of the containers, the container registry. All of them is part of the ecosystem of Kubernetes that if you try to do it yourself, it could be very challenging and a lot of work, a lot of engineering time to maintain this service and infrastructure. So here come Azure with our managed service called Azure Kubernetes Service, AKS, which take care a lot of the stuff. It's not replacing everything, but it takes care of a lot of the stuff as a managed service. As I said, it's still the open source Kubernetes deployment, but we're managing it for you. For one instance, the control plane is fully managed by Azure. You don't even need to pay for it. The master nodes part of the Kubernetes environment is managed by Microsoft and not part of your cost. You're paying only for your worker nodes. On top of that, we have a lot of integration with other services in Azure, like the Azure Container Services, Azure Container Registry, Azure Active Directory, which is now called eventID, and of course, part of the CI/CD, the GitHub, and the Azure DevOps, and many more. So this is part of the managed service you get from Azure on your Kubernetes. So we're focused on 4 pillars when we're talking about the managed Kubernetes. The first thing is built-in best practices. So besides the image of the open source of the node, of the OS and the Kubernetes, we're building the patches of security and performance on top of it as part of the Kubernetes, and we're providing best practice on that environment. We're providing unified management as a single dashboard, if it's the Azure portal or other portals I will show later, that provide you end-to-end visibility and management. Of course, there's a lot of security that we can include from the Kubernetes itself. For example, using Azure RBAC services and not the Kubernetes system permissions, and integrating with SSO or secrets or Key Vault in part of your services. And of course, the efficiency of the operations that I will show in a second, some of the features we include in part of Kubernetes services. From a developer point of view, we have a lot of services that we include or integrate part of the Azure Kubernetes service. It starts from, as I said, from the security side, from Defender, our EDR, XDR solution that can be integrated inside your Kubernetes and examine your containers from the source code to the registry to the runtime in AKS and protect your environment from vulnerabilities and data leakage and secret management and all that part of the Defender for Cloud and Defender for DevOps. We have a lot of integration with your IDE, if it's Visual Studio, even external IDE that can integrate with plugins inside of your IDE to connect with your Kubernetes service. And of course, we're focusing here on Azure Kubernetes Service, but we have other options of Kubernetes on Azure. We can also able to deploy a managed Red Hat OpenShift environment on your Azure environment. It's a co-engineered solution with Microsoft and Red Hat for OpenShift environments. Very famous for big enterprises that have a history of OpenShift environments, maybe on the on-prem, and they want to bring it into the cloud, so you can have your Red Hat OpenShift on the cloud. And also we have an Arc-enabled Kubernetes, which means that you can connect any Kubernetes if it's run on Azure or even not running on Azure, you're running on-prem or, God forbid, on other cloud platform. You can connect it as an Arc-enabled Kubernetes and enjoy a lot of the services we're talking today. It's not the day 2 operation of upgrading and patching your environment, but more giving you visibility, monitoring, security, and management to your environment as a Kubernetes platform. I'm stopping if we have any questions until now. Excellent. So part of the operational efficiency that the Kubernetes comes with is the auto-scaling solution. So here we're seeing the option to scale your application part of your Kubernetes. So the built-in or open source option is what we call horizontal pod autoscaler, HPA, which means that he listen to your pod, your containers workload, if CPU and memory mainly, and if it's get to the limit that you configure, you can scale out to more pods, part of your deployment, or scale in if it's using too much resource and doesn't need it, so we can do it. And so we have it, of course, part of our Kubernetes service from AKS, and it's managed service that is part of the environment. We also integrate with SCADA, which is an open source solution that was developed by Microsoft people that has a much more advanced scaling capabilities, like listening to Redis, to messaging services like Azure Service Bus, and also Kafka and others. So he's using together with HPA and able to bring more advanced capabilities of like listening to the queue and scaling out before even the request comes to the Kubernetes, but just by knowing that the queue is getting bigger and the messages are coming. We also enable the scaling vertically option. So that means that even the pod itself can scale up or scale down according to the requirements. It was an open source that was released, I think, only 1 year ago, something like that. And we supported as part of the AKS to enable you to scale even the pod itself and not just the deployments, but even the pod itself can take more CPU and RAM part of the environment. But we're talking about the application. Even the infrastructure itself is managed, of course, by from the AKS. So here we can see that we can scale the nodes, the worker nodes itself of the Kubernetes across availability zones in your region. So we can enable give you much higher SLA, and all that is also managed automatically, what we call the cluster autoscale. That means that according to the demand of the node workload, we can scale out and scale in your node count. We deploy more VMs on Kubernetes on Azure and connect them to your cluster, to your node pools. And they can be scaled into 3 or according to the number of availability zones that are in the region you deploy it. So that's also part of the managed service of AKS. Once you start deploying more clusters, it could be different environment, different organizations, or just different clusters in different regions. We have a fleet manager service that can control all the Kubernetes cluster in your environment. As I said, it's mainly used for multi-cluster environment. If it's you can deploy a multi-cluster service on top of a few clusters as a managed deployment, of course, in scale. And you also can manage your cluster upgrade part of the fleet management. In the not so far future, we will also enable the Arc-enabled Kubernetes part of the fleet manager. So you can onboard clusters that are external to Kubernetes. At the moment today, you can onboard AKSs, but it doesn't need to be deployed through the fleet manager. So even if you have AKS today or several AKSs today, and you want to use them with the fleet manager, you can onboard the clusters into the fleet manager, and the fleet manager itself doesn't cost any extra price to the cluster. It does have a management cluster that you need to deploy in one of the regions, and that's the only cost you need to do. That's a lot will come with the fleet manager service in the future, like DR services and layer 4 connectivity. This will come part of the fleet manager to manage multiple clusters. The Azure Container Registry is also a very critical service as part of your innovation environment of cloud native workload. That's where the place where you save your images, that you build your software that is packed inside the image itself. So we are providing Azure Container Registry service that is connected to the Kubernetes, connected to the pipeline where you deploy, you do the CI and the CD into the image itself, to the container registry. And it also has a geo-replication service that is very strong, where you can replicate the images across regions, but you still have single URL that you're connecting. So the AKS, you connect it to a single URL of a container registry, and he will know to fetch the image from the closest place that it has, and also you can manage the replication timelines and not replicating all the images, just the production images, for instance, or the latest. So it's very advanced services of a geo replication that can be part of the managed service, and also very not expensive service in that area. Where we're looking on the developer experience of working with Kubernetes. So a lot of people start with developing the Kubernetes inside the container inside on their computer. Sometimes they're running just a Docker or container, or one of the container platforms. Some even install a Minikube or full Kubernetes on their laptop to do the development. But as the scale goes higher, you need much bigger environment to do your development, to do it your testing, your integration. So even in that area, we have a lot of experience and services that can be included part of your AKS cluster. So it's starting from, as I said, integration with your Visual Studio Code plugins, interaction with the source control, with if it's GitHub or Azure DevOps for the CI/CD, and also some of the open source services. Again, Microsoft is part of a service called Bridge to Kubernetes, where it's a port forwarding tool in general. But if you have a development cluster that's running the full image, a full solution, you just want to replace a single pod for debugging, troubleshooting, testing, you can use the Bridge to Kubernetes solution just to replace one pod that is running on your laptop or your development environment with the AKS that's running on the development subscription, and you still do the full interaction with the other services. It thinks he's part of the full Kubernetes, but only one pod is replaced. So this is one of the techniques we're doing for more advanced development and experience of using Kubernetes and Kubernetes service. So here is an example of a GitHub action, the CI/CD of GitHub, of how do you connect or deploy a new application on Azure Kubernetes Service. So of course we're doing the integration with the Docker in order to push the image into the container registry, and then we're creating a secret to interact with the Azure Kubernetes service, and in the end we're just deploying the image into the Kubernetes service. It's not very complex, but it's a very easy way for developers until the DevOps do it in the production environment as well, to develop and to run their application on very easy path of CI/CD. When talking about the monitoring side, it could be on the developer side or also the production side. We have the built-in services, the Azure Monitor, with all the features and capabilities it comes with, but we're also open to the more standard open source community in this area. So we have a managed service for Prometheus, so we can interact as part of the Azure Monitor. It can work with your Kubernetes, or as I said, Azure Arc connected Kubernetes. It doesn't have any complex environment. It's pretty much just a checkbox to deploy. You just choose the place you want to deploy to, and you get a managed Prometheus service that send all the metrics. You can send them to your own Grafana, or use Azure Managed Grafana, which actually is also running on AKS. And you're not paying for the Grafana itself, although it's enterprise Grafana, but you're just paying for the infrastructure that it's holding on the AKS. And then you can have a built-in dashboards, and of course build your own custom dashboards and part of the managed Grafana. And as I said, you can also use your own Prometheus and your own Grafana as part of your Kubernetes environment, but you can also use the managed services part of the solution. Of course, all this world is all this area about AI. So we're very proud that ChatGPT, the fastest growing consumer product in history, is running on Azure Kubernetes Service. Is backed, of course, with Azure Cosmos DB and developed by GitHub. So we have a lot of relationship with OpenAI and the infrastructure that is running on. but we're using it also internally as or not a part of the Azure service itself. So I'm not sure if anyone has seen it before, but Microsoft has published a Copilot for Azure itself. It's still in preview, but the focus here is to help the Azure administrators and Azure customers to interact with Azure in a much more easy way from a free text point of view. I will share now one short demo about how to interact. What's important here that we're keeping the context of the Azure portal that will be always available, and we're adding the Copilot next to it, so we will know the context of what you're asking. So it knows your environment and knows what you're asking of. Sorry. So if you can see here, we're opening the Copilot preview solution part of the Azure portal, and we can start asking questions. Here, my Kubernetes cluster, to which container registry I'm connected, is asking on which node pool you want to connect it, asking which container registry you want to connect it to. So it's also giving you information and also providing you the command you need in order to interact with your Kubernetes cluster and your environment. So you can run the command straight from the Copilot, and you see it part of your portal that is running at the same time. Sorry. So see here, we can see it's completed the workload. The other service that we have, it's called the AKS AI. It's also a Copilot for AKS. It's a command line service that allow you also to interact with your AKS as a OpenAI prompting. So again, you can ask him to deploy an application onto the AKS. So he's building you all the deployments that you need, the bash scripts, and also we'll see in a second, you see the Azure CLI command. You will see that it will build for you the YAML file. It's the configuration file that you need in order to deploy your application. It's asking you to enter some details. So what is your resource group in Azure, what you want to do, your cluster name, and then it will deploy it for you. So again, it's interacting. It's not that you don't need to know any Kubernetes at all and not any Azure at all, but it really helps you to get advanced really fast. That's why we call it a Copilot. It's going next to you. It's not replacing you yet, but it's helping you to be much faster on your deployment and development of your environment and focus on what's really important is your application. Here we see it deploying the environment. So here you can ask a question about your environment as well. Where can I see my public IP? So you get a day 2 question as well, not just the day 1 of how to deploy, but also how to manage and get information about your environment. Really nice tool that you can get and work with. Again, it's in preview tool, so it's not fully production supported, but again, it's a Copilot. It doesn't supposed to do anything harmful. And of course, you need to always verify what you're doing. So to summarize, AKS Kubernetes, Azure Kubernetes Service is the platform that's leading all the intelligence apps that we see here on Azure. Most of our new services is running on it. So it's very integrated choice for the developers because it have interactions with the IDE. It gets integrated into your CI/CD pipeline, so it enables you to deploy your service much faster, much more simpler. Of course, it's including deployments like blue-green environments and Canary and all that, so you can roll out your services in much more safe way. And it comes with a lot of built-in services, like the scale that I showed you. You can scale on the node level and on the application level. You can do all the patching and upgrades automatic or semi-automatic that we do it for you as a managed service. And it provides observability solutions like the managed Prometheus and Grafana, and also the built-in monitoring services. get built-in security that come out of the box, like the RBAC services, the secret management, and you can include Microsoft Defender for Cloud for more deepened security protection and vulnerability protection. And of course, it comes with a managed operation that's supposed to do most of the self-healing and resilience that you need to do for environment. And the ACAS, as I said, is part of the ecosystem, part of the Azure platform for building intelligence apps. So we have the cloud native platform here in the center, but we have the community on the left side. That is, Microsoft is one of the biggest contributors into the community of Kubernetes, with add-on like KEDA and Dapper and OPA and a lot more services that's coming on the security side and the operational side. So that a lot more on the community side, of course, on the development tools. And also it's the baseline for all the other services, from the AI services, from the managed databases area, and of course the application itself that's run on the cloud native platform. I think that was me. Hope you enjoyed the session, and I'm here if we have 2 minutes left, so if we have any more questions, I'll be happy to answer now.
Thank you so much, Amir. Thank you. It was a great session. And thanks everyone for joining us today. If you have any questions, I don't see any questions now, so it means that everything was clear, I guess. But if you have any questions, then please feel free to post them in the chat. And if not,
I'm here until the end of the session.
Okay. So if there will be any other questions, we can still address them to Amir later. Thank you, Amir, and we will now move to the next speaker for today. Thank you. So here with us today, joining for the second session, is Marina Marenkov. Marina is a senior cloud solution architect at Microsoft, and she's going to do a hands-on demo on building intelligent application with AKS, GitHub Copilot, and more. So thank you for staying with us. And Marina, over to you.
Hello, do you hear me? So now I'm going to share my screen. I hope you see my presentation and hear me. So good evening, good morning, everyone. I'm very happy to be here. And a little bit about me. My name is Marina Marenkov. I'm a cloud solution architect in Microsoft. And my main focus is Azure infrastructure, cloud native services, and the Azure OpenAI service. And today I'm going to talk about the intelligent application, and mostly about the change in mindset of a developer a modern application. And I will show you a short demo how we can enhance the existing application, which is already cloud native application, and take it to the next level and make it more intelligent. So let's go to the next slide. And the generative AI makes a application truly intelligent. So in the last year, we are seeing the paradigm shift in approach of developing modern applications, the shift from modern to intelligent. So what does it mean? Intelligent applications represent a significant leap forward in the evolution of modern applications. They use the power of generative AI to create more dynamic, let's say responsive and more personalized user experience. So let's see or understand what makes an application intelligent. On the right side of the slide, we can see the 3 main points. The first one, natural language interaction. So unlike traditional applications that rely on predefined inputs, intelligent application can understand and respond to natural language, allowing for more intuitive user interactions or making it easier for people to use them. The second point, it's about data-driven personalization. These applications analyze user data to provide tailored experiences that improve over time, adapting to the user's habits and preferences. And the last point, continuous delivery of new features. This mainly reflects how developers can leverage AI-based coding tools like GitHub Copilot to speed up the developing and implementation of new features, making the development process faster and more efficient. And on this slide, you can see some elements, let's say essential elements that makes the application more intelligent. We can start with predefined, pre-trained models. We talked about natural language interaction in the previous slide. To add this capability, you can leverage existing foundation models like Azure OpenAI model or other open source models from other vendors like Meta, NVIDIA, Hugging Face, which, by the way, all available in Azure as well, not only OpenAI. And you can adapt them by grounding with your own data to fit your specific needs or to address your needs and integrate them into your application. So the next point, scalability and high performance. In the current world, application need to handle any load, any process, and analyze data in real time, in near real time, regardless of the volume or variety. So that's why scalability and high performance are so important. We have to select the technology that will enable our application to grow and scale with the application needs, making sure that the performance and the availability never compromised, even under the heaviest loads. And the last point, simplified application delivery. Again, we need to use tools and technologies. And again, I already mentioned, for example, GitHub Copilot, to be able to develop and deploy application quickly, securely, to quickly iterate on new features, and all this, or in other words, to be very, very agile. And this agility is essential for staying competitive in a modern era of AI. So what you see here, and it's actually following the elements we mentioned in the previous slide. This slide presents a very high-level design or suggestion for how you can use cloud-native application development services, cloud-scale data, and AI services together. And in the middle, you can see the AKS cluster, so which is the core of our application. In the previous session, Amir explained what is AKS, advantages and benefits. So I will not go to say it again. And AKS has a lot of, as a technology, as a platform, has a lot of benefits for modern application. For data management, we can use, for example, Cosmos DB. For those who are new to Azure, Cosmos DB is globally distributed non-SQL database service, managed service with features like low latency, global data access, and high availability with elastic storage scaling. And Cosmos DB mostly suitable for use cases like web, mobile, gaming, AI, or IoT applications. And on the right, you can connect, you can see actually a OpenAI service, and we can connect our application to Azure OpenAI and other AI services, and we have many in Azure. The AI portfolio of Azure is very, very rich. And so by using those services, actually, we can add advanced AI capabilities to our applications and improve user experience. And again, just to remind you from a previous session, for example, ChatGPT behind the scenes uses AKS cluster and the Cosmos DB. And it's exactly what you see here, the same technology, and there's a recommendation for your modern or intelligent applications. And again, all these services not only enable the development of intelligent application, but also ensure they are scalable, secure, efficient, and ready to handle the challenges of a modern AI era. And now, we are going to see demo of how all these concepts we have discussed so far are integrated together. I'm going to show you the scenario about Contoso. Contoso is a company that has made this change and modernized their application using services like AKS, OpenAI, Cosmos DB, and more. So let's not waste more time and go straight to demo website. Sorry, I'm now going to the demo site. I hope you see my screen. You see the Contoso website. So let's start to understand who is Contoso. Okay, so I'm going to show you the use case first, and then we'll see the Azure portal and the technology. Contoso is well-established retail enterprise with a presence in multiple countries. Over the years, they have successfully transitioned from physical stores to online sales through their website and the mobile application. And now Contoso has also a new CEO. Her name is April. And when April becomes CEO, she finds out that Contoso's website has some issues. Okay, and because April is a leader who relies on data, she goes and checks the dashboard. Now let's see the dashboard. This is a dashboard, and you can see many KPIs. And as you can see, most of KPIs are not doing so well. It's not green, it's orange. So, for example, Contoso revenue has been dropping and they are failing to meet sales goals during the busy sales seasons, or churn rate and outages are high, and the conversion rate also going down. You can see here, you can see the actual revenue against forecast revenue. So a lot of problems. They have many visitors, you can see here, but they are not able to turn them into transactions. This is a line behind. So now what she's trying to do, she decides to meet with her executive team to get to the bottom of the issue and to see how to solve those issues. And the CTO explained that some of challenges arising from the legacy architecture. So now let's have a look at the legacy architecture and try and understand what challenges they have or what challenges are arising from Contoso legacy architecture. So as you can see, the website application is already running on cloud and using cloud native services, but still has many problems. So you can see here the application is monolith application, is running on Azure App Service. They have API management service for managing APIs. They have Azure AI Search engine. They have database, a SQL database, and other services, but still something is not going so good. So the main problem they identify the performance issues. So when there are a lot of users at the peak time, they face outages, transaction failures, and as a result, bad shopping experience. And the other problem, for example, they have product catalog, but product catalog miss some product related information or don't have enough information. A user can't find what they are looking for, and because of inefficient search mechanism. And again, all this converted into bad user experience, and this affects revenues, of course. To address all those challenges, they decided to completely transform their e-commerce website experience and to do the following. The first, of course, they need to start from fixing performance issues by implementing, they decided to do this by implementing microservices-based architecture over a monolithic using AKS, and in order to be able to auto-scale based on API traffic. We'll see later how they solve this problem. The next one, they decided to improve the user experience by enabling AI capabilities for their online store. Next one, improve the product search experience using AI search and open AI services and implementing RAG pattern, and remove the schema dependency blocker on product information by leveraging Azure Cosmos DB. So Contoso is going to implement all these changes in two phases. And now let's see what Contoso team did at the first stage. They created new architecture. It's not final. It's a midterm architecture. It's a bit different. And the changes they implemented at this phase, the first phase, they migrated from monolithic application to microservices API-based systems. So Contoso developed a bunch of APIs, including a shopping and chat API here, a catalog and profile, order and transactions, and you can see all of them already on the diagram. The second, Contoso team developed and added natural language chat style shopping assistant called Cora. And Cora provides users with a new search experience, which is much more interactive than the previous search mechanism. And behind the scene, as you understand, and as you can see from this slide, they use Azure OpenAI and Azure AI Search. So I believe all of you know what OpenAI service is, but about Azure AI Search, so for people who are new for Azure, Azure AI Search, it's formerly called the Azure Cognitive Search, is AI-powered search and data retrieval service, or in other words, search engine. And today, Azure AI Search supports and can act as vector database and support a vector and similarity search and the hybrid search. And again, I will show you in a couple of minutes how it's implemented. And all these features together and vector store, a very robust search engine, support for vector and similarity. Search make Azure AI Search perfect choice for building generative AI-based application and implementing RAG pattern. So I'm going back to my presentation, and I want to show you one slide about the RAG augmented generation, again, for those who don't know what is it. So what is RAG pattern? RAG stands for Retrieval Augmented Generation. And actually, in short, its ability to ground your LLM. LLM, it's again, large language model with your own data and provide more personalized user experience. So in RAG, we have two main stages. The first stage, we need to retrieve and to bring relevant information. And the second step or second stage is actually integrate this relevant information from the first stage together with prompt, and they forward all this information to a LLM. In our case, it's a OpenAI. And again, all this together in order to improve or make the user experience more personalized and that address your specific needs. And sorry for jumping, but now I'm going back to the architecture. So in addition to Azure OpenAI Service and AI Search, Contoso also used Microsoft semantic kernel. It's an open source framework which acts as a smart orchestration layer to implement AI function chains. In our case, semantic kernel is consuming all new APIs and the plugins in order to add functionality to our new shopping assistant. So how the flow works? The process initiated by receiving user queries through the Contoso chat API at this point. Then the request sent to Azure OpenAI embedding API to embed the user a query or build the vector representation. Then the flow uses Azure AI Search for products to look for products based on the user's query. And then the LLM received the original prompts plus the search result from Azure AI Search, and the LLM analyzes the results and formulates user-friendly response. And the orchestrator layer, again, in our case, it's a semantic kernel, received the response and returned it back to the user. Now let's go to and see how it really work in how the website looks like. Okay, it takes a few seconds. Okay, so we have a new website with the shopping assistant. Let's go to shopping assistant, and now in free form, I can ask my shopping assistant, Cora, to help me with the different requirements or queries. And let's say I'm going to Santorini, Greece next week, and I need some turquoise blue dresses. Let's see what we will get. Okay, we are getting a all turquoise, a bunch of turquoise dresses. Let's take this one, add to our cart. Let's go to cart and we'll proceed to checkout. Again, user experience much better than old website. All information like delivery info, payment method already populated, and the last step is to pay. So let's click on pay now, and it looks that we have problem and the payment transaction failed. And what you can see on the right side is we have some KPIs on the right side, and actually what is going on, it's holidays, and we have many users in the site, and the transaction are failing. And we still, and the website still has some problems. Okay, and let's see how the team decided to address more this specific problem at the phase 2. So now to show you the phase 2, we'll go to a final architecture. Final architecture here. Okay, now we can see the final architecture. So again, we already have some services from previous step, from previous stage, and with the new services. So after the holidays, the team realized the main problem was the system's difficulty to scale. So to solve this problem, the team decided to upgrade their system with the two new services, Azure Cosmos DB and Azure Kubernetes service. You can see on the diagram that all new APIs are containerized now and running on top of AKS. And by using AKS now, they can benefit from different auto-scaling mechanisms. And again, Amir explained us about different auto-scaling possibilities like horizontal pod autoscaler, vertical autoscaling, or Kubernetes event-driven autoscaler, KEDA. And I will try to show you later. And the next significant change is transferring the database from IaaS to Azure Cosmos DB. I already mentioned many Cosmos DB advantages like low latency, high availability. In addition, all the data, we need to mention that all the data in this database is managed in JSON format with flexible schema. So Cosmos DB can handle different data types and structures, including vector data. And what the last change the team implemented at this stage was the team of engineers and data scientists decided to improve the RAG pattern to enhance core capabilities by using Azure AI Search as a vector data store for embedding vectors of products, using Cosmos DB to store chat history and embeddings of responses, or using OpenAI service embedding a model to vectorize a user query and completion endpoint to generate final output based on original query, search result, chat. And now what is new, it also chat history and the context. And of course, the last one, semantic kernel for orchestrating all those APIs, elements, and the additional plugins in order to enrich the functionality of our shopping assistant. Okay, so now let's go back to and we'll see a new you will see new website with auto-scaling. So I'm back in Contoso website. I'm going again to Shopping Assistant. I will ask to show me or give me some looks for my vacation. And as you can see, Cora now recommends groups of products as looks. and it's very nice. It not only that, but Coral also makes things that I previously purchased from Contoso and created new looks that include those items. So it's how it's possible because we are actually managing and storing the context and the previous queries and the responses. I can take from here or add to cart some of items. And again, I can ask additional looks, add to my cart, go to cart, proceed to checkout, pay now, and now it works. And of course, the KPIs now looks much better. We don't have outages, and the situation much better. Okay, so now let's see what we have in how we implement it. So I don't have enough time to go over all services, but let's see some of them. So I'm going to a Azure portal. I have resource group with the list of all services we need to implement this application. And again, we have here Kubernetes and container registry and many others, Azure OpenAI, and the AI or cognitive search and other services that we need. But let's start with the Kubernetes, okay? I will show you some workloads. Okay, I mentioned that Contoso transformed their application from monolith to a API or microservices-based architecture, and we have here the list of workloads, and some of them, the application deployments, Contoso API and the Contoso Vector Chat. So Contoso API, for example, its main service, main API or main microservice, which is handling product, order, and profile features of Contoso online store. And of course, this feature should be highly available. And that's the reason why we see here all 3 replicas for high availability is running. Other very important API or microservice, and it's Contoso Vector Chat. And in order to be able to address all load issues in our website and Contoso website, they decided to integrate the CADA. CADA again stands for Kubernetes Event-Driven Autoscaling, and CADA is used to scale out the number of pods or nodes to handle sudden demands or before any reliability issue even occur. So now I'm going to, it's implemented through the custom resources. I'm going to a custom resources. Let's search to scale. I will go to scale object, and we have scaled object for Contoso Vector Chat API. And I have a lot of very big YAML with many configurations, but only one thing I want to show you. So the example how CADA integrated with application insights in this specific case to capture events in the application in order to scale out or scale in the specific pod. The scaling of Vector Chat API service is based on defined custom events, and whenever the custom event identifies more than 10 messages, within 5 minutes, CADA initiates scaling of the Vector Chat API service pod. And as a result, this improved Contoso online store performance, improving a user shopping assistant experience. So again, Contoso implement many other Kubernetes features like self-healing, for example, and the monitoring in all this in order to improve the user experience in their website. And maybe the last one that I want to show you, this is the deployments of Azure OpenAI Studio. So we have two deployments. One deployment, chat completion based on GPT-4 model for producing responses based on prompt, user query, and the chat history and content. And the second deployment, chat embedding, is used to create a vector representation of user queries and the responses. And last one, I want to show you, we have two actually things, but very quickly. We have cognitive search with the index that already created, and the index can be based or on top of data that come from different data sources, okay? And in our case, Azure AI search can be vector store. I want to show you how it looks like. So I'm running some search query, and my results contains embedding representation of the data. And the last one, the Cosmos. Cosmos, we have one database. I already mentioned that the database is non-SQL. All data is managed in JSON format. And again, all JSON together with the main information about the products also have the vector representation. And maybe just to summarize what we did here, so using AKS and Azure Cosmos DB, now Contoso achieved higher availability, flexibility, scalability, along with the business technology advantages. And this phase core is taken to the next level where user history and context is used to respond to additional user queries. Core can also create looks, make travel-related suggestion, taking into consideration things like weather, and it was achieved by using a semantic kernel and additional external plugins. I think that's all for my side. And again, I'm going to just to summarize back to my presentation, what we saw so far, that we have all this technology in Azure that you can use and take your modern application to next level and address all requirements of the current modern AI era. So thank you very much, and over to other presenters.
Thank you so much, Marina. Thank you so much for your great session. And we will continue now to the third and last session, just to make sure that we are on time for today. So thank you again, Marina. Again, just so you know, the session is recorded and you can watch it on demand at the links that we shared in the chat. Yes, so we are continuing to the last session for today. Our speaker here is just going to join us now. Hi, Daron. Hi. So Daron Yondem is a tech lead for application innovation at Microsoft, and his session is on finding the perfect spot for your containers. Enjoy, everyone. Daron, you can share your screen now. I think you are on mute.
Oh, I was on mute. I was actually asking a question. Do we have a hard stop at the top of the hour?
Ah,
for
sorry.
mentioning.
Yeah, we are a bit over time, so we can continue 10 minutes past. And if you everyone that you can
Got it.
join, if you can't join us, you can watch the recording. But we can
Okay,
squeeze it
got
in
it.
time. Okay,
So
you can
my
my
screen is up there.
screen.
If you can, okay, beautiful, beautiful. That's all I needed. Okay, cool. So, hey everyone, I'm gonna try to make this quick, but that's an important topic as well. And our topic for today is essentially, where do I put my containers? Like, hey, I have some app, I've containerized, and this way or the other. So, or maybe I simply have some containers, and I need somewhere to host it, right? And when I look at Azure, I see all of these different options. In the previous session, there was a lot of discussion about AKS, but that's not the only solution. If you go out there and look into do some research, you're going to see that we have a couple of options. And during the next 10 to 15 minutes, I'm going to try to clarify like which direction to go based on your situation. Okay. So that's why I have the whiteboard in front of me. And for that, give me a second. There we go. So the first one that I'm going to start from is probably the most popular one is going to be app services. Oops, no, that's not the right one. Okay. So app services, the first option. I'm sure you have done something with app services. It's crazy easy to do a deployment to app services. You can do a zip deploy. You have your source code, you have your binaries. You just put it out there. It is able to scale. You can have X amount of servers hosting your app. It's scalable. It does all of this magic. It's one of the most easiest services to use, and you can actually do a container-based deployment. So if you have a container, you can go in there, select the whatever app service plan that you have, and you can do a container-based deployment. But here's a trick, at least for now. You have to have one container per app service. Okay, so an app service will be backed up by an app service plan. Plan is the big word in here. A single plan consists of multiple servers, right? And then you can have multiple app services hosted in there. But what's important is the connection between the app service and the container is usually one-on-one. You might have noticed that I said usually. Yes, you can do a multiple container deployment. There are workarounds, there are tips and tricks, but that's not the best way to go. Maybe you have a sidecar, okay, use the workaround, right? But when it comes to a solution that consists of multiple containers, right? You have, I don't know, 2 containers, 3 containers, 10 containers, and maybe more, not just your app. You have containers hosting your dependencies. You have containers hosting your database. You have containers hosting your Redis. You have all of that stuff. In that case, no, app services isn't the way to go. Okay. So if I would put into in a single sentence, if I have a monolith that is containerized, I can happily go to app services. I wouldn't worry about anything else. I have a monolith, it's containerized. I'm just using the containers as a deployment, technique, let's say, as a packaging way, right? App service is great. Put it, run it on 20, 30, whatever number of servers that you want. It's going to scale. It's going to help you out. You don't need spin up a VM and run, container runtime and, just to get your, containerized app running. But if you have multi-container, then no, that wouldn't be ideal, right? Because otherwise you're going to need to spin up multiple app services. We don't like that much, unless you have maybe 2 or 3 containers, and you can definitely orchestrate that and get the ease of use app services. But what I'm talking about is like applications that consist of 10, 20, 30 containers, and especially some of these containers, if they are hosting actually dependencies, like mentioned Redis and other stuff, maybe Elastic or whatever. So and the solution for that, to be honest, would be get the managed Redis cache service, right? I mean, it's easy to say. You might come back and say, hey, I have this particular configuration that I have to do, and the managed service doesn't do that. If that's the case, obviously you need more flexibility, and that makes sense. So, so this is the highest level solution that we have. Like, the easiest, this is the service where you put a lot of the responsibility into Microsoft's shoulders, right? So, what else do we have? What if I wanted to step down a level? With that one, I mean, hey, I'm going to take more responsibility and I need more flexibility, right? What can I do? So then it's going to be Azure Container Apps. Okay, so interesting. So in this case, what I have is I can deploy a multi-container application. I have a lot of flexibility. And this actually runs on Kubernetes. But here's the deal. So obviously you might ask, what is the difference between, Kubernetes and Azure Container Apps? And now let's go there. Let's answer that question. So, and here I have Azure Kubernetes service. Okay. First off, the way I want you to think about this is stepping down. What does that mean? I'm stepping down, I'm taking more responsibility, and I'm getting more flexibility in return. Okay? So that means when I go from app services to Azure Container Apps, I'm going to be responsible in terms of, hey, how do these containers communicate with each other? How are they going to scale separately? How will the dependency management happen and all that? And how are they going to, again, did I say how they're going to scale separately? All of that responsibility is going to be on you. But the major difference between going all the way down to Azure Kubernetes service is that you're not going to have access to Kubernetes itself, the Kubernetes APIs, and you're not going to be worried about that either. So when it comes to networking, right? Setting up the networking and making sure that all of your containers easily are able to talk to each other. All of that configuration that relates to Kubernetes, it's going to be much easier to do when you go into container apps. So unless you need direct access to the Kubernetes APIs, there's no reason to go there. Why would I take more responsibility if I don't need that flexibility? And I know flexibility sounds like, hey, that's nice, that's positive. Who doesn't like flexibility? If that means more responsibility, that means increased maintenance, increased effort in terms of maintaining the app, then I'm gonna, it's not free flexibility. That's what I'm trying to say. It doesn't come for free. It brings some accountability and responsibility with it. So I have to think, do I really want that or not? So let's turn the question around then. What would be a scenario where it would make really sense to go down that layer and get a Kubernetes, fully Azure Kubernetes service? So first off, like I said, hey, you need more flexibility. You're going to run your own stack, starting from, network traffic redirection to everything that you can imagine. Hey, I'm going to put my own software in there to do all of that. Okay. In that case, yes, you need more flexibility. Or maybe you have multiple solutions that you want to pool within a single node pool. So you don't just have one solution, you have tens of hundreds, hopefully not thousands. That would be painful. Anyway, so you have tens of solutions with tens of containers, and you want to orchestrate all of that in a single pool of hardware. In that case, yes, you need more power in terms of accessing that orchestration layer. So then, yes, you are going to fall back to Azure Kubernetes Service because it makes sense. It's going to help you do what you want to do. So you can imagine that this is a little bit of a middle ground. So app services that can only take one container, at least, ideally, let's say. And Azure Kubernetes Service where you can do whatever you want, pretty much, as long as you have a containerized app and you're fine with Kubernetes for the orchestration layer. So if you need something in the middle, you don't want to go full blown, and have, all of the worries of maintaining your Kubernetes environment. And by maintaining, I don't mean the master node. Again, that's taken care of by Microsoft, but when a Kubernetes version changes and all of the internal orchestration, you have to do it yourself. It's something as simple as, hey, we want to do, deployment slots. We want to do A/B testing. If you're going to do it with Azure Kubernetes Service, you're going to decide what type of software you're going to use within your Kubernetes cluster to enable that functionality. When it comes to container apps, too, that's out of the box. That's a functional that comes out of the box. So, okay, cool. So these are the three major options. Do we have anything else? Yes, we actually have. And that is this sneaky thing. I call it sneaky because I shouldn't call it sneaky. I should call it like, a fundamental building block. And by being a fundamental building block, the crazy flexible thing that I would say ACI. Okay. Azure Container Instances. So, what is it? Again, it's a fundamental building block. What does that mean? It doesn't do a lot. It just does one single thing, and it does it beautifully. It's crazy simple. You give a container image, it is going to host it for you. Okay. So how? Obviously, every time you give a container image, you're going to say like, hey, this is the hardware I need for this container image. This is the VM, essentially, that I need. This is the hardware I need to back up this container image. And that's it. As simple as that. So when it comes to scaling, you are going to need to do your own thing. Okay. When it comes to networking and all that, no. This is a fundamental building block. This isn't going to help you with anything other than, hey, I have a single container image and I want to run it. That's it. Okay. So if you need all of that orchestration, like, hey, I have multiple containers, I want to, make sure the traffic flows between them in an isolated, all that. That's then Azure Kubernetes Service or Azure Container Apps, or maybe App Services. Azure Container Instances, it's much more low level. Here's a little example. Azure Kubernetes Service itself can actually use ACI as a building block through the kubelet, which means when you need to scale a container, instead of scaling the node pool, you can actually jump out and bring in some ACI resources. So that's the Azure Kubernetes Service orchestrating things for you and using ACI as an underlying infrastructure enabler that is container capable. So, okay, besides this scenario, how would I, as an end user, for example, use ACI? I mean, first off, when I say end user, we're talking about developers here and IT people. But here's a scenario: you have a CI/CD pipeline, and you have this custom weird. Weird isn't the right word, but anyways, extraordinary image that you have to run with a lot of dependencies and stuff in it as part of your CI/CD pipeline. Usually it's the CI, right? In order to, do the whole thing, you'll have some custom software, custom frameworks, custom runtime, whatever, right? And you are looking for a place. So you don't need that place to live forever. You want to pay per the minute or whatever. And you build this container image because you think like it's going to be easy, like all of these dependencies and all that. I'm not going to go back to 1960s and build a VHT. So I built this container. We're using it, in our developer machines. So I need some place to put this container, and I only need to run it every time the CI pipeline kicks in. Okay, obviously a solution is to put that container into a Kubernetes cluster, but if you have a Kubernetes cluster already, maybe you reuse that cluster, or you kind of use the resources available there. But then again, you might not want to mix things up, and you might want to keep the this particular agent, whatever that is, separate from your Kubernetes cluster. If you don't have a Kubernetes cluster, then what are you going to do? Are you going to spin up a container app? No. You don't need that. Just put the container as an ACI. It's just a single command. It's a CLI, HTTP, whatever, right? However you want to communicate with Azure, you simply, tell that this is the image, this is a container image I want you to run, and this is the hardware I need. Get it up for the next 5 minutes, and then drop it. And that's all. So simply, I have a container I want to run. I don't want to touch anywhere else. Maybe I don't, or I don't want to. But, just one scenario, right? As part of your CI process. Or maybe something else. I don't know. Schedule stuff that you want to run. It makes it really easy. But when it comes to running a full-blown application that is going to scale, with multiple containers and all that stuff, no. Don't do it with ACI. It's going to be too hard to orchestrate. You don't need that. I mean, there's already solutions to do that, such as, Kubernetes services or container apps, or, not with multiple containers, but single container app services, obviously. So there's all of the other solutions to be able to do that. Okay, so these are pretty much the big pieces that we have when it comes to, hey, I have a container and I'm trying to decide where to, or maybe multiple containers, and I'm trying to decide where to host it. Obviously, you can combine these options, right? Probably not for a single solution. That would be too complicated, maybe. It depends, I suppose. But keep in mind that you can combine these solutions, especially I do see the combination of, like I mentioned, the ACI and Azure Kubernetes services through the vKubelet implementation. But there might be other combinations as well. You can always mix and match. You don't have to stick with one. Okay, cool. Let me see if there are any questions. I believe we don't have any, but I'm going to double check that. Give me a moment. Okay, we don't have any questions. So that's then just beautiful, because that's pretty much it. And it looks like I have just finished in time. I didn't need that extension. Thank you very much for being with us. If you end up having any questions, if they're watching this video as a on-demand recording, you can see my LinkedIn profile down there. Feel free to reach out, send me a DM whenever a question comes up. I'm on Twitter as well. I will be more than happy to answer your questions. With that, that's pretty much it.
Thank you so much, Daron. Thank you so much. And indeed, we didn't have any questions for your session and for today. So it really helped to finish on time. But yes, if you have any questions, thank you for sharing your LinkedIn. So feel free to reach out to Daron on LinkedIn. So thank you again, Daron. I'm going to stay here with you just for another minute and share some opportunities that we have for those of you who joined through Microsoft Partners. We wanted to highlight some trainings that you have that you can join. If you speak to your Microsoft representative in the company, we have some virtual training days that you can attend. So we wanted to share this with you. And other opportunities that we have are a website called, if you put aka.ms/pathways, you will reach a website where all the learning opportunities on AI. So it's pretty much what we shared before, the Microsoft Learn, but it gathers all other learning opportunities that Microsoft offered, and it's actually organized according to the topics, the subject, like M365, AI developers. If you're executive, so you just need to choose the level that you are in and the level that you are interested in, if it's fundamentals, advanced, and so on. And you can view the opportunities that offered free, of course, through this session, through this website. So again, it's ak.ms/pathways. These are some examples of the website and how it is organized. If you scan this QR code, you will reach more opportunities to learn and join our newsletter. So please scan this QR code to look at other opportunities to skill up and learn. Lastly, for those of you who are interested in Microsoft for Startups and Founders Hub platform, I wanted to share it quickly with you. So for those of you, the entrepreneurs here that are looking into starting your own startup, Microsoft offers Founders Hub platform. Basically, it offers you a tons of opportunities and benefits that if I wanted to try put them all in one slide, I couldn't, because it's a lot. And the program is actually for entrepreneurs from the first stage of just having an idea of opening your startup. You can sign up to Microsoft for Startups, and you can start getting credits starting from $1,000 to 150K of credits, and really lots of other benefits such as LinkedIn Premium and credits and more. So if you're interested in the Founders Hub, scan this QR code. You will reach Founders Hub, and you can learn more on the platform that we offer for entrepreneurs. That's it from my end. I hope you enjoyed the session today. Again, the session is recorded and available on demand. I hope you enjoyed it, and we hope to see you again next week at the 5th session for this series. Thank you, and bye bye.